Okay, hi. My name is Harsh Savuru. I'm a rising senior at Avon High School. I'm working under the mentorship of Dr. Zhang, and today I will be doing Seurat guided clustering tutorial. So I have two monitors here, one right here, one right here. So I'll be looking back and forth. And so I have created a Word document guide, which I'll be putting in the description box below. So if you prefer to rather read it, feel free to look at that. But I will be basically going through this guide in like a video format. So let's get started. And everything's looking, yep, everything's good. So let's get started. So first off, open R programming. So I've actually left the download link of the data set we'll be using. So you'll want to go to the Word document and download that first. Okay, now I will be loading in the various libraries. So these libraries will, like the Seurat one, will carry various functions which we'll be using for our analysis. And so it'll take a while to load because it's trying to load in the library. And next, patchwork. There'll be like a warning message. You can just ignore that. So next, you should have downloaded that data set into a safe spot. So for me, I downloaded it into my C drive. And so I'll just click through it. As you can see, it's in my C drive. And then the one we'll be wanting to open is called HG19. So what we'll be doing is we'll be using this. You'd want to copy this address so we can get access to this specific file location. So you'd want to open a text file or something that's super easy to like edit with. So the problem with one of the things with R programming is that it does not allow backslashes. So we'll need to change each one of these ones to the forward slashes. And I'll be doing that like this. And just double check and we're good. So you just want to copy that. We'll no longer need this text file. So you just say, don't save, don't need it. And so now that we have it saved, we'll be wanting to load the data set in. So I'll be actually naming this certain variable PBMC.data because PBMC stands for peripheral blood mononuclear cells. But we don't want to write that whole thing out because it's too long. So we'll just say PBMC.data. And then we'll basically be setting this as a variable. That's what the arrow is doing here. And then the read 10x is the actual Seurat function that we'll be using here. And so data direct. So that'll be where the file location is. Put it under quotes. It's kind of long, but it's okay. So the read 10x function used will basically help you by reading the output of the Cell Ranger pipeline. If you're curious to know more about the Cell Ranger pipeline, I'd recommend like doing your own research on it. So this will then return a unique molecular identifier used for a UMI count matrix. So once you load this data set, you will want to initialize the Seurat object with the raw non-normalized data. So to do that, we'll be using a certain function called create Seurat object. This is one that is also from the library we loaded, Seurat one. And so you'd want to do like counts equal PBMC data project with the project name, put that under quotes. Here I'll be putting PBMC3K. So this is basically a guided clustering, or also another way to say is like a PBMC3K tutorial is what I'm doing currently. So min.cells equals 3 and min.features equals 200, not 300, oops. And the warning, we can just ignore the warnings here. So next we can see PBMC, it'll basically list that this is a Seurat object and how many features are in the sample. So there's 1,714 features across these 2,700 samples within one assay. So, and then it'll basically give us some basic information that is very important to know. So now we'll be examining the first 30 cells. So to do that, we know we have the PBMC data, and so we'll be needing to enter in some certain like genes in a sense. And so you'd be wanting to put these under quotes because this is what the certain function will be looking for. So you'll see after that it'll be creating like a type of table in a sense. So we'll see that here. And so in this, it gave us a 3x30 sparse matrix. And this matrix will lead to like, you'll see the numbers and you'll see the dots. All right, these periods, dots. So these will be zeros. See, these dots are zeros. So this will tell you that the molecules are not, there are no molecules there. So no molecules detected. And since most values in scRNA sequence matrix are zeros, sparse matrix representation is used more frequently. This will save time and memory. And yep. So next we'll be using some various functions to various lines of code to analyze the sizes of the data. Okay, so first we'll be doing distance dot size and object dot size and as dot matrix dot pdmc data, and you'll see that everything starts to eventually like connect, and like it's just a basic programming language. If you have any past programming experience, this will be pretty simple. It's just understanding the various functions that can be sometimes tricky and like actually putting them into use. And now we can put sparse to the size. That'll tell us that, and then dense will tell us this part. And then we can divide the two like this. And you'll see it gives us 23.7